Welcome Year 10s. I trust you're having a great holiday so far. It's currently Wednesday on the first week of the holidays, and I'm guessing by now some of you are probably having withdrawal symptoms from some of your maths work, because I know you love it so much. So what I thought I'd do is, as promised, give you a video on some of the areas where we tripped up on the last test we completed in our class. So if you have a look there, you can see all of the different areas I'm going to look at in this video. So these correspond to the questions on the last exam. So we're going to be looking at scale factors, polygons. There's 5 questions there on algebraic fractions, and we're going to round off with a changing the subject question. Now just quickly, those of you who were expecting or hoping for a histogram run through, we'll be doing more of that when we come back next term. So don't worry, we will go through that. I say we'll just leave that till next term, or otherwise you can use your revision guides at home and hopefully sort those questions out. Right then, so we'll start off with scale factors questions. And this was question 2 on your papers. So if you've got your papers open, as I say, if you're going to make any changes, make it in a different colour so you can see exactly what you've changed about it. Right then, so as soon as it says in that first line there that P and Q are mathematically similar, that's where you have to think scale factors. That should jump straight into your mind. Okay, so I'm going to write that down. We're looking at scale factors. Now, there are 3 different types of scale factors we use, and they correspond to the 3 different measurements we can use for each shape. So we use the letter K for these, and we have K, K squared, and K cubed. Now these correspond to, now firstly, K is just for when you have lengths only. So when you're on the flat plane, length's what you need. When you have areas, remember area is in square units, so that is K squared. K cubed, we use this scale factor when we're talking about volume. So we have 1 scale factor, but we either square it or cube it in order to get 3 different parts. So what they've given you in the question there, they've given you that the surface area of P is 24 centimeters squared, Q 96 centimeters squared. So we're going to use the ratio. Now remember, we're talking about area here, so this is going to give us K squared. So we're going to find the ratio between the 2. Now I tend to go for bigger over smaller for this type of question, so we're going to have 96 over 24. So remember, this is what we're getting for K squared. 96 divided by 24 is going to give you, if you work that one through, 4. Okay, so that means, and we can add it on over here, that K squared equals 4. And there was a mark available, there was 3 marks for this question, 1 mark available for getting that K squared equals 4. Now, a lot of people tripped up. What they did was they times the 4 centimeters, the height of P, they times that by the 4. But remember, that's if you wanted the area. What you now want is a length. The height is a length. So we're going to do, to get to K, we're going to do the square root of 4. Square root of 4, nice and simple, gives us 2. So that means for lengths, the scale factor is 2. That means the length of Q twice as big. So we're going to do the calculation, nice and simple. It's going to be height of Q equals to 4 centimeters of P times by a scale factor of 2, and gives us 8 centimeters. Okay, and that is your final answer. So 8 centimeters is what you needed for that question. Right, now the second part we have here, let's stay on the page. So the volume, now we're talking about volume, so we're going to need to find K cubed. The volume of cone P is 12 centimeter cubed. That was the smaller cone, so we're now looking for the bigger one. So there's only 2 marks for this question, and there's not a lot to it, because have a look up again at our scale factors. Now we need to find K cubed. Now that's just going to be 2 to the power of 3. 2 times 2 times 2 equals 8. So that means the volume is going to be 8 times bigger. So there's a mark if you found out what K cubed is. Final calculation is, so volume of Q equals to 12 centimeters cubed of P times by the scale factor of 8. 12 times 8 gives you 96 centimeters cubed. And if you did all that calculation, as I say, it didn't take too long. That was worth 5 marks. So 3 in that first part there, another 2 for that part there. So as long as you remember to use K, you should be fine. Those of you that you tried to use the volume of a cone formula here, as I say, it wasn't needed. It just wasted time. In fact, it would have took a lot longer. Okay, question 6. So find the angle marked X. And what you were given in the question on the exam paper, this was a regular polygon. So all the internal angles are the same. Now, for those of you that decided, right, okay, we're going to do 360 divided by 8 because it told you that it was an octagon, gave 45 degrees, and then labeled that as one of the internal angles, shame on you. Okay, it shouldn't have been that for the internal ones. That gives you the external angles. Remember, the external angles are the ones you get around the outside there. And if you have a look at the angles themselves, you can see there they're actually bigger than 90 degrees. So no way could that have been 45 degrees. But you could use that to find the internal angles. So you could have said, right, that's 180 degrees along the straight line. So this one in here must be 135 degrees. So you could have used that to find out the internal ones, or you could have used from the video, if you're remembering, you could have used number of triangles. Remember, it's 2 less the number of sides. So 6 times 180, so there's 6 triangles in there. But then we have 8 equal angles, so we divide it by 8 at the end, and that too will get you 135 degrees. Once you have the 135 degrees, you have to use, again, the fact that it's regular, and we could make a diagram underneath this because it'll make it a bit easier to follow. So we have that shape there, so we're looking for X. Now, if you remember rightly, in the question it said, sorry, add in the 135 there, because it's a regular polygon, and you know that these two are outside edges, that means that those two there are equal. And what that gives us is an isosceles triangle. So 2 things about an isosceles triangle. Firstly, 2 angles are the same, and also 2 sides are the same. So if 2 angles are the same, we know that this one here, we colour that one in red, is the same as the other side coloured in red there. So we've got all the information we need now, because we know that in a triangle, angles add up to 180 degrees. So what we have is the 180 degrees of the full triangle, take away the 135, equals, now this is 2 lots of the mystery angle X. So we have 2 lots of that. Now if we subtract those 2, we end up with 45 equaling 2x, which means if we divide both sides by 2, x equals 22.5 degrees. Okay, so again, I think with a little more revision on that one, we could have done a bit better. So just be aware that you use the number of triangles to find internal angles, not the external angle formula over here. Right then, question 7. Now we move on to the algebraic fraction section. I think we've just forgotten how to do this, as it's been a few weeks, so we'll go through how to find it, particularly when you have a number in front of the x squared, because that changes the calculation. Now, remember, there's 2 things you have to look out for. Firstly, one is that they add together to make the number in the middle there. So they're adding to make -6. They're multiplying. Now, usually it's the number at the end here, but because we have a 9 at the front, we have to times that last number by the coefficient of x squared. So they're actually going to multiply this time to make 9 times 1, which is 9. So we have this situation up here. So we're looking for 2 numbers that add to make -6 times to make -9, and what we actually end up with is the same number twice, -3 and -3, which satisfies both of those. Now we've got to get those into the brackets. Now remember, firstly, these brackets will both contain a 9x, because we're going to divide it on later on. So at the moment it will be 9x minus 3, 9x minus 3. Remember, everything is 9 times too big currently. We divide it by 9. Now, a few people got to this step, but then decided to divide either one side or the other completely by the 9, which does work, but we try and keep them all as whole numbers. So if we see that we can't divide it fully through by 9, what we do is we try and see if one side or the other divides by a factor of 9. So if you can break up 9, you can break it up into 3 and 3, which you have a look at both sides. If you divide both sides by 3, it has the overall effect of dividing by 9, and that will leave us with simpler numbers. So if you divide both by 3, you end up with 3x minus 1 multiplied by 3x minus 1. So that was the answer to that one. You could have had 3x minus 1 squared. Didn't matter too much. The final answer, the marks would have been awarded at this point here. So 3x minus 1, 3x minus 1. Now remember, on these types of questions, because it's a part B, that means it is related to part A in some way. And the way it's related is this quadratic underneath here is exactly the same as you answered in part A. So use your answer there. Don't calculate it out again. Now, whenever you have two quadratics, one above the other, the idea is, and you always have to do this, factorize them both, and two of the brackets will cancel out. So we're going to factorize 6x squared plus 7x minus 3, because that's the only one we don't quite know yet. So same technique, they're going to add together to make 7. They're going to multiply together. Now remember, we have a 6 in front there, so it's going to be minus 18. The two numbers we need to satisfy both of these, we're going to have 9, and it's going to be minus 2. So we'll solve it in the same way. We'll put those in the brackets. Remember, they both have a 6x. So 6x plus 9 on that side. 6x minus 2 on that side. The entire thing divided by 6. Now, once again, the 6 doesn't go fully into either one of those. So we should be looking to break up the 6. And we can do that by going 3 on this side, 2 on this side. So factors of 6, 3 and 2. And that gives us whole numbers, 2x plus 3 on that side, on the other side 3x minus 1. So that's the final factorized form of the top quadratic. We know the other one from the top answer, so now going to rewrite this. Let's say I'll partition it off from that side. So on the top we have 2x plus 3, 3x minus 1. If you remember from the previous question that both of them were 3x minus 1. Now, a way you can check if you're correct on this type of question or not is that if they're asking you to simplify it, they will always cancel in some way. So if you factorize top and bottom and you find that none of them are equal, then you can guarantee you've made a mistake somewhere. Okay, so a little tip there. Right, we cancelled out those two. Those are exactly the same. So the simplified form is 2x plus 3 over 3x minus 1. So getting to the answer there, we'll have gotten you all of the marks. Question 8, so sticking with algebraic fractions, simplify this for 3 marks. Now remember, simplify usually involves factorizing, putting into brackets. Now the quadratic underneath, you can see there it's a quadratic because it has the x squared there. That one will be a little simpler to do. The top is the one that people forget to do. You can factorize the top there. 3x plus 6. It doesn't go into 2 brackets because it's not a quadratic. You can take a factor of 3 out, and that leaves you with 3, open brackets, x plus 2, close brackets. So that's the factorized form for the top. This part here, remember, this is a quadratic, but there's no coefficient of x. And that's the number they add up to. So they're going to add up to make 0 this time. They're going to multiply to make minus 4. The two numbers you're after, therefore, are 2 and minus 2. Add those together, you get 0. Multiply, and you do get minus 4. There's no coefficient of x squared this time, so that just means that we end up with x plus 2, x minus 2. Now again, you can kind of check at this point if you're on the right lines, because you can see there we've got the same bracket here and here as well. So there's going to be some cancelling down. If they didn't cancel, again, we may have made a mistake. So the final fraction becomes 3x plus 2 over x plus 2 x minus 2. We can cancel out the 2 that are exactly the same, and then we get left with 3 over x minus 2. So that's the final answer, worth 3 marks. Question 9, so write this as a single fraction. Now remember, because, and this is what throws people off, because there's algebra in it, they think they treat it differently from every other fraction. You don't. You treat it exactly the same. So what we're trying to do, imagine if you had, for example, a half plus a quarter. You can't add those up straight away. You have to create a common denominator. So that's what you're looking for here, common denominator. And remember, when we're creating a common denominator, we want every piece of everything that's in the denominators that we have so far. So for example, you see there, we want a piece of everything. So there's an x there. So that x is going to go into our common denominator. We also have an x plus 3 in both. Now, because it's in both, we only need to include it once. So we need an x plus 3 in our common denominator, and there is nothing else. Okay, that is counted for everything in those denominators. So now we have x plus 3 as our common denominator. So that's what we want for both of them. Now, fortunately, if you see the first fraction, that already has the denominator x plus 3. So that means we don't have to do anything more to that one. The second one, however, hasn't quite. We've had to multiply the x plus 3 by x in order to create that common denominator. So with a fraction, remember to not change the value. We have to do the same to top and bottom as well. So that becomes 5x over x plus 3. Now we've got the common denominator. That means we can add them together. The denominator obviously will be the common one. And it's literally now a case of addition. So it's 4 plus 5x. So it's literally 4 plus 5x, or 5x plus 4, over x plus 3. And that's your final answer, okay? Only worth 2 marks, that one. That's because the one on the left-hand side here was already in the correct form. It's just the right-hand side you had to change. So question 10. Now this one got people confused. Now when it says show that, and it's got a left-hand side equal to a right-hand side, basically ignore the right-hand side. That's what you're trying to show. So don't include it in your calculation just yet. So we're just going to take for now the n plus 2 squared, take away n minus 2 squared. Now again, something that made me terribly upset when I was marking this, okay, another sad face, was people taking this, or taking the first one and saying, right, that must be n squared plus 4, take away n squared plus 4, okay. You have to use FOIL for these. You can't just square the two numbers inside. Remember, these are brackets we're squaring, so it's technically n plus 2 times n plus 2. So if we were to write those out, so you can rewrite it as that if it helps. N plus 2, n plus 2, take away n minus 2, n minus 2, and then you can use FOIL, the bird's beak, the angry crab, whichever one you like to think of. Just lets you know, oh, going to be probably that one. Just lets you know which order you have to do things in. So we have firstly on this side, now remember we're going to keep these all together first because there's a negative sign in the middle. So we're going to go n squared, then it gives us 2n, and then another 2n. So I'm going to group those together for now and go 4n, and the final number is plus 4. Then we're going to take away, again we start with n squared, this time we have minus 2n, and minus 2n is the middle two numbers, so that'd be minus 4n. The last one's minus 2 times minus 2, gives us 4, close the brackets. Right then, so we're not far from our answer now. Now remember here we have negative sign in the middle. That's going to change the sign of everything this side. So we're taking away everything here. It's going to change all of those signs, and it means we can cancel down. So this side stays the same. So n squared plus 4n plus 4. We're going to take away an n squared now. Minus 4n becomes a plus 4n. Minus 4 at the end becomes minus 4. Now I'm going to cancel this down in different colours, just so you can see exactly what's going on. If you look at what the situation, the n squared's there, you've got an n squared there, and you've got to take away an n squared there. So n squared take away n squared gives you 0. We can cancel those down. The same with the numbers. So if you look there, we've got 4 and a negative 4. So we can cancel those down because they add up to equal 0. All we've got left that doesn't cancel down is a 4n here and a 4n here. Add those two together, you end up with 8n, and that's what the question was asking you to show. So you needed to just ignore the right hand side at first, take the left hand side, expand it out, cancel it down, and then you should have found the right hand side was 8n. Right, not long to go now, so for question 11, simplify this one here. So again, if you've been paying attention in the first one we were doing, you need to factorize the top and the bottom. So factorizing the top one, so 4a minus 20, let's say this is on a quadratic, so you just need to pull out a common factor, and it turns out for this one it's 4. And that leaves you with a minus 5 inside the brackets. The second one, now they're going to times together the two numbers to make minus 25. They're going to add together, there's no x term in there, to make 0. So again, we're going to be left with the same number, positive, negative, and that number is going to be 5 and minus 5. So that factorized comes out to a plus 5, a minus 5. The quick visual check shows again that we've got two that are the same there, so it's a good thing that we can cancel them at the end. So the final fraction comes out as 4, a minus 5 over a plus 5, a minus 5. So those two that are the same will cancel, and you are left with, and I say it's worth writing this down afterwards, 4 over a plus 5. So that was enough to get you 3 marks there. You can see how quickly, once you know the technique, that can be done. Right then, final question, question 14, make x the subject of that expression there. Now the difficulty here, and why it's worth 4 marks, is that there's two x's that we're going to have to group together. One of them is even in the denominator, so we're going to have to sort that out straight away. So we don't like working with denominators, we don't like working with fractions when we have changing the subject questions. So the first thing we're going to do, now you can use a method here called cross multiplying. So if we have two fractions and nothing else at all, what we could do is times both sides. Now if you wanted to get rid of this fraction here, you'd times both sides by x plus c. That has the visual effect of shooting it up across over to that side. If we then wanted to multiply both sides by q to get rid of this one, that would have the same effect as shooting it up over there. So we end up with, if you times, or if you made your first step timesing by x plus c, and then your second step by q, it has the same effect. You should have been left with qx on this side, p. Now remember, because it's a little expression under here, x plus c go together, so that's p times by, open brackets, x plus c. Now we have to dig out the x from the brackets, and we can use the noddy hat to times this out. So we end up with px plus pc. We still have qx on the left hand side. Now we need to get all the x's on the same side of the equation, so we're going to subtract px from both here, so it will be qx minus px equals pc. Now we've got to try and group those x's together, and the way we can do that is we can take it out as a factor because it's common to both. Pull out an x, and what we're left with is q minus p, and obviously that still equals pc. Then to get x on its own, we can divide by q minus p. So x equals pc over q minus p. So to get there, if you got to this point here, you got all 4 marks. Obviously, if you've done some of the working, you say there was full marks available there, so there's quite a few partial marks available for showing the correct technique in places. But I think what people struggled most was that part at the top there, the cross multiplying. Once you had that part done, I think you could have got there. So just be aware, when you've got fractions, try and get rid of those first to get to your answer. Okay, so I hope that helped with that exam. If you've got any more problems, to say, give me an email over the holidays. I'll try my best to answer that as quickly as possible. Otherwise, bring it in the first lesson back and we can talk through it a little bit more. Okay, ladies, so I hope you enjoy the rest of your holidays and I'll see you in 5 weeks. Take care.